So we convert negative 2/5 here, again dividing. I'm going to do 2 divided by 5. And as far as the negative goes, I'm not going to worry about it. I'm going to do 2 divided by 5, and then once I get an answer on the calculator, which is 0.4 by the way, and then I'm just going to stick a negative back in the front of it, which is how I get negative 0.4. So I'm comparing negative 0.44 and negative 0.4. So in the first spot after the decimal, these are both 4, so there's nothing to compare. In the next spot, this is a 4, and there's absolutely nothing here even. So realize that would be the same as if I had a 0 there, because 0.4 and 0.40 are exactly the same thing in the world of decimals. Well, obviously 4 is greater, but remember, we're talking about negatives. Negative sign, negative sign, negative sign, negative sign. We've got to consider that we're talking about negatives here. Remember, when we're bigger in the world of negatives is when we're closer to 0. So negative 1 is bigger than negative 2. So that means in this case, perhaps that looks a little strange based off what I said earlier, that 4 is bigger than 0, but it's because they're negative here. Negative 0.4 is going to be a little bit closer to 0 on the number line than negative 0.44, which is why we're saying that this one is bigger. Now remember, this did not start off life, though, as negative 0.4. It was negative 2/5, which is why they're saying here that negative 0.44 is less than negative 2/5, or read the other way, negative 2/5 is bigger than negative 0.44. Okay, we won't fool you with negatives in the next one, because the next one has no negatives. We're comparing 1/9 and 0.1 here. So 0.1 we're probably not going to change, but 1/9 we're going to divide that out to go decimal. And remember, again, you have the option to go all fraction here if you want. But remember, that's going to require common denominators, which might be a lot more work in some cases. Going decimal, because to change that fraction to a decimal you're just going to divide, probably with a calculator, is probably going to be less work. So I did the 1 divided by 9 for the 9th and got 0.1 repeating. Well, 0.1 repeating is obviously larger than 0.1. How is that so? Think about comparing the place values. The first place value here is both a 1, so that's nothing to talk about. But the next spot, because this 1 repeats, if I actually had to write it out, would be a 1, but this one is a 0. So it's the same logic as what we saw up here, but this time they're not trying to fool you. They're not putting negatives on there. Since the 1 would be bigger than the 0, the 0.1 repeating is larger. But remember, it didn't start as 0.1 repeating. It started as 1/9. So we say 1/9 is bigger than 0.1. Okay, we'll continue on with the next example here. And the next example is talking about now arranging numbers in order on a number line from least to greatest. Here it says that the numbers 14/4, negative 3.4, 6.0, and negative 2.5 represent the percent of change in populations for 4 states. List these numbers in order from least to greatest. This is again also a good review of what we just talked about just a few seconds ago. Remember, the smallest numbers when we're in negative territory are the ones that are furthest away from 0. Whereas if we were in positive land, all right, it would be the opposite. So we're going to look at the numbers furthest away from 0 in the negative land being the smallest, and then working back towards the positives, which we know how those work. So, to compare these here, you have to compare them all in the same form. So you want to compare them all as fractions or all as decimals. I definitely don't want to compare these all as fractions, not because I can't handle it, but because I have to change 3 of them. That's just simply more work. It's easier to just change the one fraction. So you're going to change the 14/4 into a decimal. So I'm going to do 14 divided by 4, probably on a calculator, and I get 3.5 when I do that. Okay, so we've got 3.5, negative 3.4, 6.0, and negative 2.5. Well, let's start with 3.5, or 14/4 says it started. 3.5 would be halfway between 3 and 4. So that is obviously this dot that you see on the number line here, again, as I stated, directly between 3 and 4. Negative 3.4, well, that's heading back this way between negative 3 and negative 4. It's not quite halfway between the negative 3 and the negative 4, because that would be negative 3.5. It's just actually going to be a shade to the right of that marker. So this here, this dot, represents negative 3.4. 6.0 is the equivalent of just the number 6, the whole number 6. So that's the one you see furthest to the right on the number line, right on 6. And negative 2.5, well, that's the one that would be halfway between negative 2 and negative 3. Think about it. If we want to break it into smaller increments, this would be 2.1, 2, 3, 4, 5, 6, 7, 8, 2.9, and then we get at 3. And remember, those would all be negative. So negative 2.5 is the dot that's halfway between negative 2 and negative 3. So now all we have to do is to put those numbers in order from least to greatest. And that's quite simple because, again, we're just going from left to right as we look at the dots. So negative 3.4 is the one that was furthest to the left, and then negative 2.5 moving towards the right, and then 14/4. Remember, we converted that to 3.5, but it did originally begin life as 14/4, and then 6.0, which is the percent changes in population in order from least to greatest. We'll conclude this presentation with the check it out examples, numbered 1 through 3. The first question there is asking us to compare 1/3 and 1/2. So, what have we learned in this section? Well, we've got a few different options here. We could, if we wanted to, change these all into decimals. All right, that is probably the least amount of work because we're just going to simply divide to do that. But since we did practice getting common denominators here, let's actually do that. So we've got 3 and 2 as denominators here. Well, if I listed multiples of 3, that list would go 3, 6, 9, and most of you are already screaming that you've seen a match because you've seen an even number appear. And indeed, you're correct. The 2 list is going to go 2, 4, 6, and the match is at 6. So the denominator that's common to both of these fractions, not just a common denominator, but the least common denominator here, is 6. To change 3 into 6, we'd be multiplying by 2. So I'm going to multiply the top by 2 as well, and 1 times 2 is 2. To change 2 into 6, we're going to multiply by 3 here. So I'm going to multiply the numerator by 3 as well. 1 times 3 is 3. And now that I have a common denominator, I can compare these. Now the sign that's the answer shouldn't surprise you at this point because remember, once you have a common denominator, we just compare the numerators, 2 versus 3. Well, obviously 3 is larger, so the sign is going to eat 3/6 or be filled in with less than. 2/6 is indeed less than 3/6. If you want to think of it the other way, 3/6 is bigger than the 2/6. Now, in the second question, they're still asking us to compare, but this time they have a fraction and a decimal. So you make a decision at this point if you want to go all fraction or all decimal. And certainly from what we've seen, all decimal is the winning approach. So you're going to do 6 divided by 10 on the calculator, which is 0.6, or I can write it as 0.60. And the reason I'll do that is simply to achieve balance in comparing these things. It makes it easier if we have the same number of digits both ways. Now remember, as we discussed earlier, when we're in negative territory, the closer you get to 0, the bigger the number is. If you want to think about it another way, think about how these things fall on a number line. Where are the biggest numbers on a number line? The biggest numbers on a number line are always to the right. So whichever one of these would be furthest right on the number line is going to be the biggest number. So we look at this and say 6 and 6, that matches, so there's no comparison to be made there. But here's 0 and 4. Think about it. Negatives, negatives. This one is actually going to be a little bit further away. This one would be a little bit to the left. If you're still having a hard time with that, forget that there's decimals for a minute. If this just said negative 64 and this one just said negative 60, we know then, because we've been dealing with just negative integers for a long, long time. From 0, we go to negative 1 and negative 2 and negative 3, and we would keep going, negative 58, negative 59, negative 60, negative 61, negative 62, 63, 64. Well, the one that came first, as we're looking compared to 0, was negative 60. So that means that that one is actually bigger because it's closer to 0 in the world of negatives. So this one's going to fill in with less than. Negative 0.64 is less than negative 6/10, or if you want to think of it the other way, negative 6/10 is bigger than negative 0.64. Let's look at the final question there, number 3. Again, we're putting numbers in order from, in this case again, least to greatest. You'll want to look out for that tonight. Make sure they don't try to throw a question at you that says greatest to least. We've got negative 1.2, 7/3, and 2.3. So all of these need to become one form, either all fraction or all decimal. Since 2 of them are already decimals, let's finish the job and make them all decimals. So you're going to do 7 divided by 3 on your calculator. And when you do that, it's going to be very similar to something else that's up there, except instead of just 2.3, it's 2.3 and the 3's repeat. You'll notice on your calculator the 3's carry off from the decimal all the way to the right of the screen. So that's 2.3 repeating. So now we're going to put those in order from least to greatest. Now, the one that should be a dead giveaway that we shouldn't even have to think about is negative 1.2. Negative numbers are always smaller than positive numbers. So that's why negative 1.2 goes first. So then all we really have to think about is this 7/3, the 2.3 repeating, and the 2.3. Well, think about if I wrote another number here. If this didn't have the repeating and I just wrote it like a calculator, the next number would be another 3. But this one would be a 0. 230 versus 233. Well, 230 is smaller. So that means 2.3 goes next, and then the 7/3.